So when we talk about good software design, what we're trying to get to is this idea of modularity. So modularity is this idea of taking our program and breaking it apart into different modules. Remember when we talked about subsystems and modules? It's the same terminology here. But with modularity, we have a set of goals in mind. We don't just want to break it up willy-nilly. We want to break it up in a smart way. And with this, what we're trying to do is two main goals. So with our module, let's say we have a piece of code right here. With our module, we want this module to be independent, and that is the coupling part. Independent means that all of its actions and data only affect itself. We don't have a module over here controlling it and a module over here controlling it, and then maybe it's controlling a module over here, and this one's controlling that, etc., etc. Then you get into this really big problem of an error here might actually represent itself up here, or actually it could go and represent itself all the way over here. You get a problem when they're not independent. So that's one of our goals, and that's what coupling is. We'll have a whole lecture on that. And then cohesion is how singular does a module sort of exist like. What I mean by singular are its goals singularly designed? If the goals are singularly designed, we can take that module, we can remove it from the program and put it in another program. If we had a web page and this web page had this controller in it, and this controller controlled everything. I mean, it's talking to a whole bunch of other controllers. So maybe it's got actually pretty good coupling in the sense that even though it's controlling all of these, nothing controls it and its data is very sort of encapsulated within itself. But the problem here is that it's very, very fine-tuned to exactly this problem. Meaning that if we ever try to take this out or put a new piece in, it wouldn't work. This is very, very specific to this exact problem. So it doesn't meet a singular design goal. It's doing everything. There is no goal. I mean, you could, say control website. That could be your goal, but that's a very broad goal, and it's not something that's very singularly designed. And that's when we talk about cohesion. So with modularity, we're trying to get those two aspects. We're trying to get them both as optimal as possible. We're trying to make it very independent and then very singularly designed. So the goals of modularity. The goals of modularity are as follows. There's a different set. I mean, if you look up the goals, there's going to be different sets for any people who talk about this. However, this is a set that I like to go off of. The first and foremost goal of modularity is abstraction. It's basically taking our module and putting it into a black box to remove complexity. And we're going to be talking about that information hiding in a little bit. But abstraction is very important because it allows us to design higher level ideas. If we had to, for example, work on machine language, which means we're actually, controlling ones and zeros all the time, we wouldn't be able to get anything done. It would be too complex. But someone has abstracted that out to an assembly language. So this is assembly. And then someone has actually abstracted that assembly language up to probably another one, and then up to our language like Java. So we can use Java with its relatively easy to use functions. It then decompresses it down into whatever this language, that goes to the assembly language, that goes to machine language actually controls the RAM, etc. So when we're talking abstraction, we're talking the ability to take these complex ideas and slowly bring them out and remove that complexity so we can build more and more advanced programs. Decomposability and composability. It means we can take the thing apart and put it back together. This helps with debugging. This helps with adding new features. This helps with basically anything that has to do with maintenance. Is we want to be able to open this program up, take everything apart, and then put it back together again. And that really helps when you have both of these in line, is because you can take this controller out and it doesn't break the entire website. You can actually, sort of hot swap a new controller in, maybe one that does stuff slightly differently, more efficiently. It becomes very easy to maintain after that. Module understandability, or just understandability if you want to keep them all as one word here. What understandability means is that I could jump into a module and instantly understand what it's talking about. With this one, it's very, very in-depth. This might be maybe, let's say 35,000 lines of code. Do you think you'd be able to understand what this module is doing right off the bat? Probably not. But let's say we have this small module over here, and all it does is do maybe updates on the database. So all it does is update database. And maybe that's its name, and there's functions like update integer, update string, update user, update password. We look into it, we say there's a problem with updates within our database. We instantly can go, well, let's check the update database folder or the file. And it's very easy, very quick to understand. The next one is continuity. Continuity is a little bit of an idea where you have, let's say, you're using constants. Constants is a very good way of putting this. We have x equals 3. So instead of having in each one of these aspects a variable of x equals 3, 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 imagine if now in our situation x equals 4. Well, now we have to go through each one of these and change them to 4, which is going to be, we're going to miss one, and then we're going to have weird errors start popping up. It's going to get hard to maintain. But if we had a constant folder, if we had a constant file up here that said x equals 4, well, then all of these could just reference that constants file. And this is getting a little bit messy now, but I'm trying to, bring home that point right there, is that if we had that constant folder up there, then all we have to do is change it in one place and it'd be continuous throughout our entire project. So having that in mind is very important as well. And finally, protectability. The way that we can protect data is if we keep it very, very sort of on lock in specific files. We don't have, 85 different files contacting the database. We have a single controller or a single set of controllers that do it. This not only helps us with unintended consequences, it also helps us against hacks and stuff, because if we have 86 different entry points into our database, all that has to happen is one of them has to fail before someone jumps in. So getting that under control is very, very important, and modularity helps you maintain and get a stronger security. So that's the introduction to modularity. In the next lectures, we're going to be talking about information hiding and data encapsulation, which are other key tenets of modularity.